this next week is a busy week for you. You have so many tests, so I will postpone the test to 22nd of May at 4 p.m. Okay, so last time we talked about pulse excitation and rise time, and we considered first of all rise time for undamped system. So the force, which is given as piecewise continuous from 0 to T1, it is a rise, and then from T1 and on is a constant. We can use the principle of superposition, and applying the convolution integral for this type of problem will be much easier than solving the differential equations on interval by interval. Okay, so the force, or the pulse, is given as a rise, which is this is rise, and then a negative, this is positive rise, and this is negative rise. When you find the solution due to F1, we know it is valid up to T1. You cannot use that for T greater than T1. But when you use the principle of superposition, it means you will find X1 due to F1, and you will find X2 due to F2. And if F1 will not terminate at T equal to 1, it becomes 0. So we have to cancel the effect of the positive rise for T greater than T1. And this is why F2 is added. Okay, F2 is going to cancel effect of the positive rise and only give us the constant. Okay, and as I told you, to get the F2 that will cancel the positive rise and give you constant is by making F1 plus F2 for T greater than T1 to be equal to F0. And this way you can find F2. Okay, so we find F1 and F2. Now we find the response. Okay, we did it here. Okay, so to find the response, we can use the convolution integral for x equal to. So first of all, we can say response. Since we have F1 and F2, we can find the response due to F1, which is F1 is a rise or positive rise. Or this is called RAM as well. Okay, so x is equal integration from 0 to t of f of eta, h of t minus eta, d eta, and we will use h of h for unda. Okay, so this example is for h of t is 1 over m omega n sine omega n t. And you can also put it as omega n over k sine omega n t. This is for undamped system, zeta equal to 0. Okay, now substituting for f of eta is going to be f1 of eta. Okay, so let me just put this on the side that f1 of t is equal to f0 over t1 times t. In the convolution integral, we have f1 of eta, so we have to replace, whenever there is t, we replace it with eta. So f0 over t1 is a value, not the variable, times t, then it is times eta. H of t minus eta, h is equal to 1 over m omega n sine omega nt for undamped system. So 1 over m omega n sine omega n. Instead of t, we put t minus eta d eta. That is the substituting or in the convolution integral. So the terms that are not function of eta, we can take them as outside the integral and becomes independent of eta. So we can take them outside. So it is f naught over t1 m omega n, and the integration from 0 to t of eta sine omega n t minus eta d eta. And we can use the integration by part. I can use the first column, so it is 1 and then 0. Integrating sine is minus cosine, but there is a minus here, becomes a plus. Divided by omega n, and we integrate home once more. This will be minus sine omega n t minus eta divided by omega n squared. So remember, we are integrating with respect to eta, and there is a minus in front of eta, and this is why we have plus here and minus for the second. And then you multiply this term by this term to get the total. Okay, we multiply this by plus and we multiply this by a minus. Okay, so x becomes f naught over t1 m omega n, and as a result of the integration we have eta cosine omega n t minus eta divided by omega n multiplied by plus, so it is a plus, because there is minus and minus, becomes a plus. 1 times sine omega n t minus eta divided by omega n squared from 0 to t. This is the limit. And when you substitute, this will be f naught over, you can take 1 omega n outside. Okay, this becomes t1 divided by m omega n squared. And then when you put the limits, you will get t cosine omega n t minus t plus sine omega n t minus t divided by omega n minus 0 multiplied by cosine omega n t minus 0 minus sine omega n t minus 0 divided by omega n. Okay, so we have cosine omega n t becomes 1, and sine 0 is 0, and 0 multiplied by cosine, the whole thing will be 0, and this will be sine. So the result will be simplified into f naught over t1 m omega n squared is k, and this becomes t minus sine omega n t divided by omega n. Okay, in the final form, we take t1 inside the bracket. Okay, so this is f naught over k t over t1 minus sine omega n t divided by omega n t1. Okay, this is the final equation for the rise, the positive rise, and this is valid for t less than, and you can put equality of less than or equal to T1. Not valid for T greater than T1. Okay, because this is assuming that we have the rise is is open from 0 and on. But we know that at T1 and greater than T1, it will be the rise will change. So since we are using the principle of superposition, we can find a solution due to F2 or the response due to F2. And then add the two responses. We can call this is X1, which is the response due to F1. Okay, and then we find the response due to F2. Which is a negative rise. Now, when you find the response due to F1 or due to F2, you assume that the system is subjected to F1 only and subjected to F2 only. Okay, so that's the meaning. You have force is a rise. This is F1. And for F2, you assume that the system is subjected to F2 only, which is 0 for T less than T1, and then start to have F2. So from 0 to T1, F2 has no effect on the response, or it is 0 response. Okay, so you can use X2 equal integration from 0 to T of F2 of eta, H of T minus eta, d eta. But you know that from 0 to T1, there is no response. So this will start from T1 to T of F2 of eta, H of T minus eta, d eta, and you can carry on, carry out the integration as we did for X1. But you can simplify instead of repeating the integration again. F2, if you write it as we derived it last time. Okay, let me take you back to this page, which is minus F naught over T1 times T minus T1. Okay, so I will repeat it here. It is minus F naught over T1 times T minus T1. If you compare this with F1, okay, F1 is equal to F naught over T1 times T. Okay, so this is equal to F naught over T1 times T minus 0. Right? I'm not changing anything here, just putting T minus 0, which is T. So with this comparison, wherever there is F naught in the solution due to F1, wherever there is F naught, you just change it to minus, and wherever there is T, you change it to T minus T1. Okay, so let me just repeat X1 here. X1 is F naught over T1 over K. T over T1 minus sine omega n T divided by T1 omega n. So X2 will be, I have a minus sign here, which is negative. It means I will put minus F naught over K. And wherever there is T, I will put T minus 1 divided by T1 minus sine omega n T minus T1 divided by T1 omega n. That will be the solution whenever I have rise. So the integration, we did it, and we will use it for any force that is rise, we have to do the integration again because this will be the same. So you don't need to do the integration. You can use this result. In the formula sheet, this is given. Okay, so it is called response due to rise. It's given in the formula sheet. So whenever there is a rise, whether positive or negative, you just need to substitute in this equation with the appropriate values. Okay, so suppose we have F1 equal to 10 over 50 times T. Then if not is 10. Okay. Then X will be, and X1 will be 10 over K, whatever K is, T over T1 minus sine omega n T over T1 omega n. Okay, if F2 is minus 10 over 50, no, this 50 is too much. Okay, let's say 0.1. So this will be T over 0.1 divided by 0.1 omega n. Okay, so F2, let's say it is minus 10 over 0.1 T minus 0.1. Then X2 will be minus 10 over K T minus 0.1 over 0.1 minus sine omega n T minus 0.1 over 0.1 omega n. As simple as that. Okay. Okay, suppose I have F3 is equal to minus 20 over 0.2 T minus 0.2. So those two, this is T and this is should be the same. Okay, you make sure that the equation for F as a rise is written as T minus T1 over T1 times F naught. Okay, so we'll take this as F naught and we take this as T1 and this is T1. Always make it in this way. Okay, so suppose it is not given this way. Let's say this is given as minus 100 times T minus 0.2. Okay, then this 100 is the result of dividing 20 over 0.2. So you have to break it down into an numerator and denominator. So this should be, in the denominator should be 0.2. And this should be minus 20. This will be T minus 0.2. Okay, you make it in this form, if not over T1. So wherever that the rise is given, just make sure it is written in this form. If not over, this might be positive, it might be negative, it doesn't matter. Okay, so this you take the whole thing as if not with the minus. Okay, so after finding x2, and as I told you, you don't have to do the integration again. You can use the response due to rise and use it. So that is the second equation we have here. Now, the actual response is not the same response as x2 because you need to apply the principle of superposition. x2 is valid for t greater than t1. Okay, it means before t1 it is 0. So the actual response will be Okay, we have to give it interval by interval. For t less than or equal to t1, x equal to x1 only, and you can substitute for x1. Okay, which is if not over k t over t1 minus sine omega n t over omega n t1. And for t greater than t1, the response is x equal to x1 plus x2. This is the principle of superposition. As we did with f1 plus f2, that is the final force. F1 plus F2 equal to F naught for t greater than T1. We have to do the same thing with the response. So the actual response is not X2 for t greater than T1. It is X1 plus X2, and then you substitute for X1 and for X2, and to make it simplified, this will be T over T1 and T over T1 from X2 will cancel out, and then you have minus sine omega n t plus sine over T1 omega n. Okay, plus sine, sine omega n t minus T1 over T1 omega n. Okay, I hope I'm not. So there is 1 here, 1 plus. Okay, 1 minus sine omega n t over omega n T1 and plus. Okay, let me check. Okay, so here is the slides for response for due to F1 is F naught over k t over T1 minus sine omega n t over omega n T1 for t less than T1. The second RAM, which is I called it X2, F2, is starting at T1. The solution can be rewritten by inspection of the foregoing equation as x equal to minus F naught over k t minus T1 over T1 minus sine omega n t minus T1 over omega n T1. So instead of doing the integration again, you can just do the modification on the first solution. And by superimposing these two equations, the response for t greater than T1 becomes F naught over k 1 minus sine omega n over omega n t over omega n T1 plus 1 over omega n T1 sine omega n t minus T1, and this is valid for t greater than T1. Okay, so that is the idea. And using convolution integral, as you can see, we didn't use initial conditions for the second interval because the equation already is for 0 initial conditions, and the principle of superposition is used. Okay, if you use the differential equation, solution of differential equation, it means you have to apply initial conditions at the beginning of each interval. Okay, clear?
Yes, doctor.
Okay, good. This is the first, this is part A, this is constant with the rise. The second is rectangular pulse. Rectangular pulse, again, we will use the convolution integral and applying the principle of superposition. So let me rewrite this. Here is the f of t, which is suddenly if not up to T1 and then 0. Okay, so the force is if not and then 0. This can be made equivalent to a constant with f naught, and I will call this as f1, which is equal to f naught, plus another constant starting at t1, when this is negative, minus f naught, which is f2. Okay, how do we obtain f2? We know that f1 plus f2 equal to 0 for t greater than t1. And this will give us f2 equal to minus f naught, minus f1, which is minus f naught. The response to a constant is, so response due to f1, and f1 is constant. We already did this in example, maybe number 2. X equal to f naught over k, 1 minus cosine omega nt. Okay, let me take you back to the maybe this lecture. Okay, so this was the solution. F naught over k, 1 minus cosine omega nt. Okay, so for due to f1, which is a constant starting at t equal to 0, you have x equal to x f naught over k, 1 minus cosine omega nt, and you can call this x1. Now response due to f2, which is again it is a constant but negative, starting at t1. Okay, so the response will be the same equation above with the we apply the modification that we have f2 is equal to minus f naught. So it is minus f naught divided by k, 1 minus cosine omega n. Instead of t, put t minus t1. And we know this is valid for t greater than t1. This is valid for t less than t1 or equal. The actual response you give it, you know, specifically for each interval. So for t less than or equal to t1, x equal to x1, and then you put x1 equal to f naught over k, 1 minus cosine omega n t, right? And for t greater than t1, x will equal to x1 plus x2, and then we substitute and simplify. This will be f naught over k, and this will be minus cosine omega n t, minus, and minus becomes plus cosine omega n t minus t1. Okay, so let's see the solution. Okay, so already we have the response to a step function in one of the examples that is given as amplitude ratio here, kx over f naught is 1 minus cosine omega n t for t less than t1. The response to the second step function started at t equal to t1, and it is negative, and this is why there is a minus here. It is amplitude ratio is kx over f naught equal to minus 1 minus cosine omega n t minus t1. The total response, okay, by adding the response in the second interval becomes, you add x1 plus x2. Okay, it is kx over f naught is 1 minus cosine omega n t minus 1 minus cosine omega n t minus t1. Simplifying becomes minus cosine omega n t plus cosine omega n t minus t1 for t greater than t1. So already we have this response. This is one of the responses equation, and this is the second responses equation. Okay, so x is given as piecewise interval, piecewise continuous. So it is if not over k, 1 minus cosine omega n t for t greater than, for t less than or equal to t1. You can put the equality in any one of the interval. And if not over k, minus cosine omega n t plus cosine omega n t minus t1 for t greater than t1. So always it is like this, given as piecewise continuous. Okay, the third one is half sine pulse. This is more realistic than rectangular pulse because this is shown as suddenly, if this is an impact force or contact force, then this is shown as suddenly it is if not. Okay, if you have a hammer and you hit an object or you hit a system or a structure, then it might take this shape. This is more realistic. Okay, half sine pulse. So it is starting with 0 and increasing to maximum if not, and then decreasing back to 0 at T1 and then stays 0. Okay, the solution, there is an exact solution for this, which is shown here. Okay, this is the half sine pulse. And you can apply convolution integral or differential equation to find the final solution. Okay, which is, I will not go through this in details. And this is the final equations. We have T. Okay, this is one equation. And this is the second equation, as we did with the rise and with the constant. Okay, but I usually skip this part in exams. This is not because it is not important. This is important, but since if you understand the concept, then you can apply to half sine pulse or to any other pulses. Okay, so I will skip this just to make it easier for the exams. Okay, so this is the part of lecture 2, and we can skip this part, then we can move to lecture. Okay, lecture 3, in fact, part of this chapter, there is numerical methods. But since we already have a complete course in computer application, which is I'm also teaching, is 380. We solve differential equation using MATLAB, and in 274 also you solve differential equations numerically using numerical methods. I will talk about the exact solutions. Okay, here is an example. This is required. Solve the differential equation using convolution integral. 4x double dot plus 2000 x equal to f of t, where with 0 initial conditions and subjected to the force shown below. So we have the differential equation, of course, shows mx double dot plus kx equal to f of t. M is 4 and k is 2000. The force is given as a pulse with a constant, and then there is a negative rise, and then 0. So the changes here are over three intervals, not just one. Okay, from 0 to 0.1, this is the first interval. From 0.1 to 0.2, this is the second interval, and greater than 0.2, this is the third interval. So there will be x1, x2, and x3. Again, the force, you can see that from 0 to 0.1, F equal to 100. Okay, this is F1. And from 0.1 to 0.2, F is equal to F2. And from 0.2 and on, we should have F3. Okay, so there is F1 here, and there is F2 here, and there is F3 here. How do I know they are F2 is negative? How do I know that F3 is positive? You know, it is by experience, but you can find it. You can find F2 and F3 as we did in if you follow the same procedure we did in the previous types of excitations like rise and constant or the rectangular, you will find out F2 and F3. You know, F1 is not difficult. You can observe it as 100, right? Which is F naught. It is 100. So how do we obtain F2? Is by saying for the interval greater than 0.1, less than or equal to 0.2, we know that F equal to this equation. Okay, which is equation of a straight line, which is AT plus B. Okay, equation of a straight line. You know how to find the equation of a straight line. You need the slope. The slope is 0 minus 100 divided by 0.2 minus 0.1, which is delta F over delta T times T minus 0.1 plus F at 0.1, which is 100. Okay, this is the equation of a straight line. Okay, equation of a straight line, F equal to M, which is the slope, times T in general, yani, let me write equation of a straight line in Y minus Y0 equal to Y2, okay, Y1 here, Y2 minus Y1 divided by X2 minus X1 times X minus X1. Okay, this is the equation of a straight line. Okay, so you can apply this on F. You take those 2 points. This is point number 1, and this is point number 2. So we have at point 1, we have T1, which is 0.1, and we have F1 is 100. At point 2, we have T2 is 0.2, and we have F2 is 0. So when you substitute in this equation, you get the final thing is that F equal to minus 100 over minus 0.2 over 0.2 minus 0.1, which is 0.1. This is minus 1000 times T. Okay, and 1000 times T plus 100 becomes plus 200. Okay, so this is the final equation after simplifying. Okay, minus 1000 T plus 200. This is F. Okay, so if you apply, as we did in the previous cases, that let me just move this to the other side. Okay, so we have F1 equal to 100, which is for T less than, I will call it T1, and T1 is 0.1. Okay, less than T1. And F2 or f1 plus f2 should equal to f, which is minus 1000 t plus 200. And this is valid for t greater than, you can put equality here. Right? Okay, T1, you can call it, I mean, 0.1, you can call it T1, and 0.2, you can call it T2. Okay, from here, we can find F2. So it is minus 1000 T plus 200 minus F1, F1, which is 100. So this will reduce to minus 1000 T plus 100. Okay, we take the 1000 with the sign, negative 1000, as common. So this is T minus 0.1. So we know this is T1, right? 0.1 is T1. This is a rise because there is T, negative rise. Starting at T equal to 0.1, which is, I mentioned, I added to in the graph. But remember that this minus 1000 is the product of, is a result of dividing if not over T1. So we need to have T1 in the denominator, which is 0.1, and here it is T minus 0.1. It means this is minus 100. So if not is minus 100. This is the value. So this is a negative rise starting at T1, and you need to make those forces ready, and then you can apply for the, to find the response. Now this is for this interval. For the third interval, okay, this is interval number 1, interval number 2, interval number 3. We have f1 plus f2 plus f3 should equal to what? For t greater than 0.2, we should have 0 force. So f1 plus f2 plus f3 should equal to 0, and this is valid for t greater than 0.2. This is the third interval, from which we can find f3, the unknown, which is minus f1 minus f2. Okay, I will take the minus common. And what is f1 plus f2? You go back. f1 plus f2 is minus 1000 t plus 200, right? So this becomes, and you put a minus, becomes a plus 1000 t minus 200. Again, you take the 1000 common here, you get t minus 0.2. So this is a rise, positive rise. As you can see, there is t, then it is a rise. Starting at t equal to 0.2 second. So I need to make this as if not over T1. So this will be 0.2 here and T minus 0.2. It means this is 200. So if not is 200. Okay, when you come to the actual or to the response due to each one, to each forces, to each of the forces, so you will find response due to F1. F1 is a constant. And we know the response to the constant, we already derived. We don't have to do the integration again. Okay, so this will be, I will call it x1 equal to, if not, over k 1 minus cosine omega n t. Okay, omega n is square root of K over M, which is 22.36 from the given differential equation. Okay, so square root of K over M. K is 2000, M is 4, so this becomes 22.36. And then you substitute here, if not is 100, which is F1, divided by 2000, 1 minus cosine 22.36 T. And this is valid for T less than or equal to 0.1. Okay, a response due to F2, and F2 is a negative rise. I'll call it X2 equal to, for negative rise, we have minus if not, the whole thing is if not with the minus over K is starting at T2 at T1, so this is T minus T1 divided by T1 minus sine omega n T minus T1 divided by omega n T1. Okay, we have, if you go back to F2, it is minus 100, the whole thing. Okay, if this is confusing, we should include the minus. Minus 1000, minus 100 over K, which is 2000, T minus 0.1 divided by 0.1 minus sine 22.36, T minus 0.1 divided by 22.36 times 0.1. Okay, you can simplify this. Then the final response due to F3, which is positive rise starting at T2, which is 0.2, then we can call it X3. This becomes, if you go back to F3, it is 200, that is F naught. So 200 divided by 2000, T minus 0.2 divided by 0.2 minus sine 22.36, T minus 0.2 divided by 22.36 times 0.2. Okay, and then you find the actual response. I think this is neatly written here. Okay, just last 1 minute, 1 more minute. Huh? Okay, response due to the constant is F naught over K1 minus cosine omega n T, which is 0.05 times 1 minus cosine 22.36 T. For the RAM or positive rise, sorry, negative rise, we have X equal to minus F naught over K T minus T1 over T1 minus sine omega n T minus T1 over omega n T1, and we have minus 100 over. From F2, we have minus 100 over 0.1. So this is minus 100 over 2000 becomes minus 0.05, minus 0.05, T minus 0.1 over 0.1 minus sine 22.36, T minus 0.1 over 2.236. And then positive RAM, starting at 0.2, we have F naught over K, T minus T2 over T2, minus sine omega n T minus T2 over omega n T2. T2 is 0.2. F naught is 200 over K, 2000 becomes 0.1, T minus 0.2 over 0.2 minus sine 22.36, T minus 0.2 over 4.472. Those are 3 responses. The actual response is obtained interval by interval is for T less than 0.1. The response is given by equation 1, which is X1. And for the interval from 0.1 to 0.2, you can put equality anywhere. This becomes X1 adding equation 1 and equation 2. And this is the result after simplifying. And the third interval is by adding the 3 equations, equation 1, equation 2, and equation 3. And simplifying, we get X equal to 0.05. This is the final equation. Okay. So we have one more example. We can do it next time and also solve the problems. Okay, there will be quiz on Sunday inshallah. This coming Sunday.
فأي tutorial دكتور؟
Tutorial 7.
tutorial 7. دكتور المحاضرة
all the problems of tutorial 7. نعم.
دكتور الريكورد مع المحاضرة اللي طافت من دقيقة 20 وفوق كان شو اسمه اللي تكتبه ما يبين يعني في الشاشة.
نعم. Okay. I will see the other section. I will make a copy of the video and put it in your team.
اوكي دكتور مشكور.
لا. يا سلام.
مع السلامة.